500 product reviews, one call to a language model for each one. Each call takes about 2 seconds. You write the obvious loop, you hit run, and 17 minutes later it finishes. Here is the strange part. Your computer did almost nothing for those 17 minutes. It was not calculating, it was waiting. Let me show you the 3 lines that turn 17 minutes into about 100 seconds, and the 1 line that stops you from getting blocked while you do it.
First, where does the time actually go? Every call does the same thing. You send a request out over the network, then you sit there. The model thinks, and about 2 seconds later, the answer comes back. Almost all of that is traveling and waiting. Almost none of it is work your processor is doing. Now do that 500 times, one after another, and you get 17 minutes of mostly nothing. The waiting is the program.
Here is the code almost everyone writes first: an async function, a for loop, and a wait in front of the call. It looks concurrent. It has the async p word, it has a wait, it reads like modern code. But watch what it actually does. It starts one call, then it stops and waits for that call to come back before it even starts the next one, 500 times. The word await is doing exactly what it says. It waits.
This is the trap, and it is worth saying plainly. Await does not mean concurrent. Await means pause me here and let the event loop go run something else in the meantime. But in that loop, there is nothing else. You never gave the event loop another job to do. So it pauses, it sits idle, and it resumes. 500 times in a row. You wrote asynchronous code, and you got sequential timing.
Now the fix. Instead of awaiting each call one at a time, we build all 500 coroutines first and hand them to asyncio.gather in one go. Gather takes them, schedules every single one of them on the event loop, and then waits once for all of them together. Now the requests are out on the network at the same time. The log clock stops being the sum of 500 calls. It becomes roughly the length of the slowest single one.
And that is the whole mechanism. Before, your timeline was 500 bars in a row. Now it is 500 bars stacked on top of each other. The work did not get faster. One call still takes its 2 seconds. You simply stopped doing them one at a time. This is the part worth keeping. When your program is slow because it is waiting, you do not need a faster computer. You need to wait for everything at once.
Now, a quick detour because the name confuses people. Gather is not named for the speed. It is named for what it does with the results. It hands them back in the order you passed them in, not the order they finished. If review number 3 was your 3rd argument, its answer is the 3rd item in the list, even if that call came back dead last. That ordering is the whole product. Its sibling, as completed, gives you results in finish order instead. The word itself comes from parallel computing, where MPI-gather collects one value from every prowl array, indexed by rank. Fan out, then gather back in order.
So we are done, right? No. Run that against a real provider and it falls apart. At time 0, you just opened 500 connections. Your provider allows, say, 60 requests a minute. It is not being difficult. It is obliged to refuse most of what you just threw at it. You get a wall of 429s, too many requests. Unbounded fan-out is a self-inflicted outage. You traded 17 minutes of waiting for an instant denial.
Here is the fix, and it is one object. A semaphore is just a counter of permits. We make one with 10 permits. Now every call has to take a permit before it is allowed to run. That is the async with line. 10 core routines hold a permit and are in flight. The other 490 are parked at that line, waiting their turn. When one finishes, it releases its permit, and the next one walks through. We still call gather. We are just gathering bounded work now.
And the arithmetic is easy. 500 reviews, 10 at a time, 2 seconds each. That is 50 rounds of 2 seconds, about 100 seconds, not 17 minutes, and nobody refused you. Notice what the semaphore actually controls. It does not make anything faster. It decides how much of your work is allowed to be inflate at once. That number is yours to choose, and it should come from the provider's limit, not from optimism.
One more piece, because 10 in flight does not make you immune. Limits are counted per minute. Other jobs share your key. Providers have bad days, so when a 429 does slip through, you catch it, you wait, and you try again, and you make the wait grow a little longer each time. 2 seconds, then 4, then 8. That is exponential backoff.
So hold these two apart because they are not the same job. The semaphore is how you avoid the rate limit. Backoff is how you survive the one that gets through anyway. One is prevention, the other is recovery. If you only have backoff, you spend your life apologizing for a burst you should never have sent. If you only have the semaphore, one bad minute takes down the whole batch. Ship both.
So the whole thing, a wait inside a for loop is sequential. That is not concurrency. That is a queue with extra syntax. Gather puts everything in flight and hands the results back in argument order. A semaphore bounds how much is in flight, and that bound comes from the provider's limit, and backoff catches whatever still slips through. 17 minutes, down to about 100 seconds. 3 lines of code.
If that made Gather click, hit like and subscribe. I take one concept and go all the way down to the code, every time. There is a 90-second version of this in the description if you just want the summary. Next up, what happens when 2 of those 500 coroutines reach for the same variable at the same moment?